In this video, I am going to explain linear regression. If the if the output variable is continuous, we should apply any of the regression algorithm. Here you can see the height is a target variable, the data spread is continuous, so we can apply any of the regression algorithm. So, if is there any linear relationship between input feature and the output feature, we should apply the linear regression. Let us take an example here. The age is an input feature and the height is a target variable. By plotting the line plot, we have found that there is a linear relationship between feature age and the target height. So whenever the new data came across you, you should check the linearity between the feature age and the target variable. So in order to check the linearity, we have some methods like scatter plot and line plot, and we have to check the collinearity and covariance between the features x and y, and we have to check is there any linearity. So if we found some linearity between the feature x and y, we should go with the linear regression. Let us see how the learning happen in linear regression. Let us take an example. We are having the 100 rows of data. We are having 100 rows of data with the features age and the target height. So we are teaching each of the row to the model. Let us take an example. For age 1, the height is 1.2. For the age 2, the height is 1.4. Like the same way, we will teach the entire data set in to the model. So after teaching all these data points, based upon the data, it will find a pattern. So since it is a linear regression problem, at the end, it will find a mathematical equation for the y in terms of x with the formula y equals to mx plus c. So after training entire data set, it will find a pattern like a straight line. So whenever the new data point came across the straight line, it will predict using y equals to mx plus c formula. So here we have to see how the model is evaluating these m and c values. So if the data is so simple like with the limited rows, we can find the slope by using this formula y equals m equals to y2 minus y1 by x2 minus x1. But if the data is having 1000 rows of data, if the data is having 1000 number of rows, we cannot able to use this formula. So in order to solve this problem, we are having a Pearson correlation coefficient method. By using this method, we can find the values of m and c easily. So here age is the input feature and the glucose level is the target feature. So we have to make some feature transformation like we have to find some equations x by x square and y square. So we have to submit all these values into this equation and we will find the m and c. So by using this m and c, we will the model is build a equation y equals to mx plus c. Here, the m value is found by this equation and c value is found by this equation. When the x is the new data point, so by using this equation, it will directly find the value of y. So before training the data, we will split entire data into two categories. One is the training purpose training data, and one is the test purpose test data set. So for this, we will train the model using this train data, and we will find the performance of the model by using the test data. For this test data, we are having the value of x and we are having the value of y, which is the actual value. So, but by using the model equation, we will find the value of y using the formula y equals to mx plus c. So, let us take an example x equals to 1. We and we will by substituting the x equals to 1, we will find a new value y. This is the y predicted, and we will have the y actual also. At the same time, at the same way, we will find all the values of y predictions. And after predictions, we will plot a graph. Let us take an example. Here the data point which is lying on the line is predicted value, and the data which is above the line is actual value. So the difference between these two is error. So we should select the values of M and C in such a way that the error should be minimum. So how we select the M and C values in a way that the error should be minimum? We can randomly select some of the M and C values, and we will find the error for each and every data point, and we have to select the M and C values which are giving the least errors, which is a very time-taking process. But the SKLN linear regression is using ordinary least square error in order to find the M and C values. So finally, we have find the M and C values, but the problem with that M and C values is we are getting the error is high. So in order to re- reduce the error, we should select the M and C values in such a way that the error should be minimum. Okay. So in order to select the best M and C values, we have two methods. One is the OLS method, another one is the gradient descent method. So OLS, the linear regression, the SKLN linear regression is using OLS in order to perform the best M and C values. So we are the first step in the OLS method is we have to find the error function. So in OLS method we are using MSC as a error function. Why we are selecting the square difference function is, let us take an example. The y is the actual data point and p is the predicted data point. The difference between the y and p is the past two. If the data point is lying above the regression line, if the data point y lies below the regression line, the error should be negative. So at the time of doing the summation, the positive and negative will be cancelled. We will get and we will not get the accurate error. So in order to resolve this problem, we are doing the square of the difference, and we are using MSC in the OLS algorithm. In OLS method, we will find the MNC values by doing partial derivative of error function with respect to MNC and equating to 0. So after doing partial derivative with respect when equating 0 by after some iteration of the mathematical calculation, we will find the best values of M and C. These are the values of M and C which we will use in wireless method. These are the best M and C values which will give the least error. So af- by using these M and C values, so we are training a model with the wireless method, which will we are training a model with we are training a data set with the wireless method, and we will find the best MNC values. By using those MNC values, we will finally predict the outcome using this formula y equals mx plus c. So this all about wireless method. So in wireless method, first we will find the error function which is the MSC. By using the MSC, we are derivating the MNC values. So this is why we are getting that MNC values are giving the least error. We are we are getting the MNC values from the last function only, from the error function only, right? This is why we are getting the least error by using these MNC values. So the gradient descent is an approach which is the iterative approach, which is the one of the method to finding the MNC values. So here we will check the last function as a differentiable function because differential function is only having one global minima. So this is why we are selecting the mean square error as a last function over here also. So in the first step in the gradient descent algorithm, we have to initialize the M and C values randomly. Let us take an example. Here we have initialized as m equals 0 and c equals 0. So after the initialization, we have to evaluate the gradient of cost function with respect to each parameter. We have to find the gradient of cost function with respect to m. We have to find that gradient of cost function with respect to c. So by using these two equations, we will find the dm and dc values. So after evaluating the dm and dc values, we will going to find the new slope values by using those dm and dc. So by using these slope values, we will again check the error rate. If the error is less, we will proceed further and we will do this iterative process until we get the error is less. Let us take an example here. We have started at the point A where the m value equals to 8. So after calculating the dm and dc, we have find the new value of m which is 4, where m equals to 4, we are at the point B. So here the error rate is less. By going to the negative slope, we can see that the error rate is decreasing. So we are doing these steps, we will find the values of C, we will until we will reach to the global minima. We will find the M and C values in such a way that until we reach the global minima. At the global minima, we will have the best M value, which will give the least error. So this is all about the theory behind the linear regression. With the in next video, we will see the code for the linear regression with the wireless method and gradient descent method. Thank you.